Okay, so hi everyone. Hi new joiners. We will wait a few minutes before we starting. We'll let others the option to join us. We have 7 attendees at the moment. Today we have Shiri with us, and
Hello.
she will talk with you about really interesting stuff in these days. How to take advantage of some technologies to do some remote coding. Am I right, Shiri?
No, it's about Azure Zero Trust. So it's
Oh,
about
right. Yes, 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 yes,
for developers. So it's about how to make sure you are working as developers in the most secure way you can. But it's really interesting when we're gonna finally drill down to the bottom of this overused terminology of Zero Trust.
yeah, I was a bit confused, and but she actually delivered a similar session, right? That's why I was kind of confused. I remember when you showcased how to use Visual Studio Code to do some virtual coding.
Yeah, we have on Thursday another. It's not a part of the Hackorona. It's we have an GitHub Actions session. Not that, but you published it as Azure Zero Trust.
So today we start
Yeah,
with your stuff. Okay.
for
So I
developers.
think
Yeah.
that's actually a good time to start opening the session. So before I'll hand it over to you, Shiri. So this is a Hackorona webinar. As some of you already know, we have it every single day at 6 p.m. I'm here hosting a virtual session. Today we have Shiri with us. Shiri, she's a cloud solutions architect, and we work actually together in the same team, and she's awesome.
Yeah.
Um,
Wow. It was all worth it just to hear it from you.
that's being said, I think that's a good momentum to hand it over to you. So I think you should introduce yourself, and the virtual stage is yours.
Thank you. So hi, my name is Solution Architect, and I work in the same team as Idan with ISVs and startups. My previous role, and basically though my specialty, is about security. And today I wanted to talk to you, as the line here states, about zero trust for developers. So we're going to basically review what the hell is zero trust, because it's a kind of terminology we hear quite often, and its 3 aspects, and how us as developers and not necessarily IT or IDM configurators or whatever can help implement it and make sure that both our code and the application we develop, as well as applications and services we use as developers, are safe. So I promise it will be really quick, but a minute, like what is zero trust? So it's a buzzword that basically Forrester coined it on 2010. But even before that, Jericho Forum, which is a forum of CISOs, basically sort of set this concept of deparameterization, meaning we are no longer operating in a world of parameter that everyone works either from the office or connect to a VPN. And basically what it means that we have an approach that we treat every access to any kind of our organizational resources as if it was originating from an untrusted network. So obviously, when we were talking on a pre-corona days to some organizations, including, I believe, some of yours, it would be like, okay, so certain things you're not able to do if you're coming from an untrusted network. But I believe that if we look at current affairs for a second, zero trust is no longer a hype. It's sort of a must, because everyone are now, or almost everyone, I hope that all of you are working from home, and meaning all the traffic that you originate to your organizational resources, databases, applications, services is traffic is over the internet, and it's originated from outside of the corporate network, and whoever already had in place a zero trust strategy and now takes a huge advantage of it. So when we think about the model, it basically says that everyone are coming through the internet, and we want to look at certain parameters or characteristics of the specific session they are going through in order to decide what to do about that. And it basically says we don't have any trust in the session or in the user that it says who is actually is, and we are now based on some parameters we'll decide how much we trust him and whether we want to challenge him again. So the 3 principles of zero trust that we will review today, there can be others, but since we're talking, you guys are all developers, I assume, so we'll focus on that, are centralized identity provider, use least privilege access, and no public IPs. And we'll drill down to each one of them very quickly. So first of all, why should developers even care about identity? And the reason is that usually it's a kind of talk that we do with CISOs, but I listed a few answers here, which I think should be really important for all of you. So first of all, because you should try and link all of your apps and services to use a central identity, and I will explain what the benefit of that soon. Because service principals are evil, because we don't want to have service principals which are shared among different developers, and you are texting to your colleagues your credentials to the SQL DB on your WhatsApp group. Because I want you to not get upset when you're prompted to MFA to have a second factor, but truly to understand the logic that stands behind it when you're challenged. And because you need to think about stronger authentication for the apps you develop, because hackers are like having fun right now, and we obviously don't want to. We want to make sure that all the apps we're developing are safe, and we have strong authentication mechanism in place to make sure that it's working. So identity is a new control plane, and I want to explain when I said that we should all strive for centralized identity. It actually makes you think whether it's safer or actually not as safe, because you think to yourself, if we have only one identity, meaning a hacker that comes and being able to hack these credentials, he would be able to get to every application you have, right? And overall, we have some sort of perception that security and productivity are sort of like that don't come hand in hand, and meaning as long as we are like challenging the user more or ourselves, and we have a more complex password or multi-factor authentication or whatever, meaning we are safer. But it's actually not true, because think to yourself, if you have 5 different set of credentials when you log into it, Azure SQL, you have one a set of credentials, and when you SSH or RDP to an Azure VM, you have a different set of credentials for this dev machine. And when you log into your email, it's a whole different set. Eventually, you will end up, first of all, using way easier passwords, and second of all, every time you type these passwords in, it's an opportunity for the hacker, which is just standing there and waiting to be able to harvest your credentials. So actually using one centralized identity as a control plane makes perfect sense. And also because if you think about that, identity is a new parameter, because the old parameter is basically having this firewall with our users, devices, applications, and data all like, you know, surrounded with a big wall. But when we look at the new world, and especially now working from home, then you have users all over the world logging in from all kinds of devices to a lot of SaaS applications, but also to applications which are in the corporate network. And basically the parameter, like we cannot put a wall around all of that. But what we can do is set one door, like one entry point. And the good thing about it is that, as I said, it gives you the ability to say, okay, I will really invest in this and have a very complex password because I only need to type it in once. And on the other hand, for the management, for the SecOps or the IDM guys, for them, they need to look only at a single point, a single pane or a single point of entrance to make sure what is going on with you. And just think to yourself, it's very difficult to find some anomalies when there are cross applications, or if you, for example, log into an app service application that you deployed on Azure from Tel Aviv, and then 10 minutes later, you will log into some kind of I don't know, your SAP success factors or whatever to change your address or whatever, then from the US, no one would be able to see it unless you're using the same credentials. So it's also easier for you guys to use the same credentials, your corporate credentials, but it also actually is more safe. The other thing I wanted to highlight is why I actually use our identity platform. And this is because, so Azure AD holds over a billion identities, and we have 45 billion daily authentications. Just think to yourself how much it means we know about authentications, about how a normal, good login should look like versus a bad login, like two failed logins before successful ones. Is it okay? Is it not okay? We sort of have enough data to be able to actually derive some insights about that. Basically, we have this sort of a security graph, which is built over all the data that we get from anyone who has Windows all over the world, everyone who has an Xbox who plays with, everyone who actually still uses Bing or Edge or use, as I said, Azure AD authentication. So all of these signals give us a very good understanding about if you are really who you are, which is a new parameter. Also important for me to highlight that the Azure AD is not meant to use just for Microsoft applications. So obviously, it makes sense for us when we use it to log into Windows or to Office applications. But what interests you as developers, that I would strongly recommend to use your corporate credentials also to GitHub, also to Jira, also to ServiceNow. All these applications, basically any application, even one you developed, that supports XAML authentication can be, or OAuth 2 or PinID Connect can be easily integrated into Azure AD. So we talked about authentication for apps. And now I want to take you to another aspect of it and talk about authentication to your services. So also, you can still use Azure AD authentication when you want to, again, log into some kind of platform as a service. So Upservice supports it, and Azure SQL, and Event Hubs, and all of this. So again, instead of sharing some kind of like credentials which are permanent, or using those keys when you need to rotate the keys and renew them and do all this management process, you're able to actually use your own credential, have a single sign-on experience, and also give each developer the rights that you need to. So if one developer should be able to read from a database, we can give him a role of a reader, while we can give other a role of a writer, and not just play with hundreds of different accounts which are credentials or keys which are written in clear text or hashed if we are really good in the connection string. Another issue, if we look at the platform as a services themselves, is obviously service principals. So as I said, we all know service principals are evil. We don't want to put them in clear text. We don't want to sort of have them for anyone to use them. But we still don't kind of figure out a better alternative to that. So what we usually do is we create some sort of a service principal, which is a user. Essentially, we grant permissions, and basically this user, we get the credentials, we secure those credentials, we add the service principal credentials. Those credentials need to be rotated and cleaned up afterwards, and also we need to make sure we delete the service principal if it's not relevant anymore. With managed identities, it's so much more simple. So we basically can go to any kind of Azure resource, and I'm talking about VM that you are on the wizard that you build it, or after you can go to the IAM blade on the left-right side. And basically, every resource, almost every resource in Azure, has its own, let's think about it, unique identity. And it's sort of a service principle behind the hoods, obviously, which is associated with this specific resource. But the good thing about it, we secure it. We as Microsoft, we handle all of this strong authentication behind the scenes, all of this key rotation and encryption and hashing. And basically, you are able to take these credentials and say, for example, this Azure VM supposed to be reading from a reader, has a reader role on this Azure SQL database, and it has a role of a contributor or administrator for an app service. And you basically can sort of give those permissions without creating the user or make sure that you're responsible for that identity. There are three types of managed identities, which I will go really fast on, but it's important to understand the difference and the strengths. So basically, think to yourself, you have a virtual machine or an Azure function, and you want this function, for example, to be able to get a key from the key vault, or you want the app service to be able to go and grab a photo from a blob storage on Azure, or a virtual machine to be able to, let's say, go and read data from Azure SQL DB. So basically, essentially, the way I would refer to like the way we can do that is three different ways. So it's like you say you have keys to your house. So basically, if someone goes and steals those keys from you, he doesn't need to do anything else, right? He just needs to steal the key and he's able to get to the house. So this is a way we think about identities, which are like credentials like username and password or SAS keys, meaning the moment someone has their hand on it, this is it, game is over. They can get into your house. The second option, which is basically system-assigned managed identities, is built-in garage door remote, meaning someone cannot actually steal the keys because you don't have keys to your house. You have a garage door remote, which is in your car, and basically someone needs to steal your car, but then he will also and then he will be able to use those keys to get into the garage, which are in the car. But it basically means you cannot just grab your keys and run. And this option, it basically means that you have this identity assigned to a specific resource, as I said before. So this VM has its identity, and it has like it is authorized to do something in other Azure resource. The bad thing about it that this sort of managed identity is tied up with the resource, meaning when the resource is deleted or something happens to it, you cannot keep the identity and it's dead, so things can break. The third and the option that gives you the most granularity while keeping you safe is a user assigned managed identity. And this sort of lets you have both of best of both worlds, I'm sorry. And basically it means that you, as some sort of a resource, you know that there is one resource you need to be administrator of and another resource you need to be reader from, etc., etc. So you're able to create this identity, which is like not tightly coupled to any of the resources. And basically, it's like having sort of a garage door remote, but it's handheld. So you can take it out of the door and you can give it to someone else, but then he wouldn't be able to yet steal the car. So it's like saying we have this identity which is not necessarily attached to a specific virtual machine. So if one of these virtual machines does not exist anymore, still the rest of the authorization that was associated with this managed identity will work. So here's a list sort of it's kind of old already, and you can simply like hit this link like aks.ms/Azure Managed Identity Status. But basically, I would say that it's a huge priority for all of us in Microsoft to make sure that all services support have, first of all, Azure AD integration, because this is the first step to have a managed identity, and then also support managed identities. And if you got me correctly, meaning that every service you look, you need to think to yourself, first of all, how do you allow yourself and your team as developers to authenticate against that service? And please do that with Azure AD, your corporate credentials when possible. It's also easier and more secure. And also, how do you make sure those resources connect to each other and authenticate to each other? And it's best done through managed identities. The privileged accounts problem. Another problem that I believe you all as developers will relate to a lot is obviously users that has to have high permissions, and we're able to do whatever they want. And obviously the number of times that you are like, who did that, or who deleted this record is, it happened to all of us. So basically, the privileged account problem, our approach to this, and this comes to the second aspect I was talking about of zero trust, which is basically list privilege. I'm sorry, it's a list. Give the least amount of access that you need to. And basically what it means, we say no one needs to be an administrator at 2 a.m. in the night. And no one needs to be able to, I don't know, to change passwords in that time of the day. So basically, we don't want to have administrators with standing access. It's just wrong. And what we do is we can use the privileged identity management, which is a part of the identity protection on Azure AD, to say basically what users are eligible. They are eligible to be some kind of administrator, but when they do actually want and need to act as administrators, then basically this is a time that they will try to activate this. They will need to go through some sort of authentication mechanism, which can be sort of granted to them after review or automatically, or require MFA. And this is sort of a great way to still let those people be administrators. And sometimes it's even about them improving themselves. But you know they will be logged, and also you know that if someone managed to take over the credentials, it doesn't mean that he will get administrative access. It has access problem. So we all know we don't sort of want to have any kind of public IPs to any kind of our resources. I guess you all know that. You have your way to get around this, but today I want to review about some basic strategies you can do to make it even better. So just a quick overview. We all know virtual networks are virtual networks, or VPCs, load balancers. We put usually before the virtual network to decide like how to map the traffic to what port. And we'll go through the rest. So basically, first there was endpoints, service endpoints, and what we wanted to do is we didn't want to allow access from the internet to our Azure PaaS platform services. So if we, for example, had a blob storage, it had a public IP because this is the way service endpoint work, but we are able to sort of configure that you can reach this specific instance, let's say blob storage, only from your private virtual network. And the downsides of that were two. First of all, you weren't able to say, I allow access from my virtual network only to my instance of the blob storage or the SQL, but you would have to grant access to your VNet to the service in general. So any blob storage out there. And also, you wouldn't really get rid of the public IP. So your Azure service would still have a public IP, your SQL or your whatever. The only thing is you would sort of use network security groups to make sure that this public IP is accessible only from your virtual network. So the new and exciting thing, it's not so new, by the way, anymore, but they load more and more services there, so it might be now relevant to you as it wasn't before, but it basically means you can actually deploy an instance of any kind of Azure service, whether it's Azure SQL or blob storage or any of that, without having to give it a public IP at all. Meaning finally, when you deploy this instance, you are allowed to access it only from your virtual network, but also the two things I said before, it doesn't have a public IP at all. So it has only private IP assigned with it. And then second of all, from your virtual network, you need to open a connection only to this specific instance that you have. So you're not now opening your virtual network and letting it have outbound, like going outbound to blob storage in general, but to your own instance of blob storage, which is awesome. So again, there is sort of data exfiltration protection, meaning you don't just get access to the service, you get access to your own instance of the Microsoft service. You basically get the service sort of as if it was deployed in your own virtual network. It's not actually is true, but you sort of make it happen through your security groups. So again, it's sort of today it's for us the Synapse and for the SQL DB and for blob storages, and obviously you should go and check what other services are allowed. Another, and I think we're getting close to the end, another problem which is about not accessing the services which we just discussed the past, but how do you make sure you access your IaaS, your VMs in the most secure way? And obviously, again, RDPing or SSHing is not a good idea. So again, so when we think about a common sort of deployment that you have in the clouds, so you would have your regions, you will have some Windows machine that you will need to have ports 3389 open to be able to RDP, or port 22 open if it is Linux to be able to SSH to those machines. But what I would say is like, try and put some sort of machine with this public IP and 22 or 3389 port open, and see like that after exactly 1 second you will start being attacked. And the reason is Microsoft basically publishes the list, like the IP range, the list of IP ranges every month, and basically all hacker needs to do is to download it and to literally go through every address in those public IPs, which is port scanning, and try 22 and 3389 till he finds someone like you who didn't protect their public IP and open one of these ports to the public internet. And also, so one of them is not, if it's not protected, or try to brute force it. So obviously, I know you guys are smarter and you're not just putting your VMs, whether they're Windows or Linux, out there with ports open to the internet. But what you do usually is one of the following solutions. So a very common solution would be if you sort of have your on-premise network and your Azure network, you would sort of define a subnet, which will be gateway subnet, and you will allow sort of this connection with site-to-site VPN between the subnet, which will be like your DMZ in the cloud, and your on-premise. And this way, sort of, this traffic is not over the internet. It's like site-to-site VPN is a secure connection. You can do it also with ExpressRoute. But if you do need still to have your machines be able to access them from the internet, for example, because you're no longer in your corporate network and you're working from home, meaning you do need to have a public IP. So a common use was, for example, to use Azure Load Balancer as some sort of a scam to go behind, to try to avoid this, and basically say that if you try to access this public IP in a specific port, let's say port 5000, it will redirect you to a certain server. And if you try to use a public IP with port 5001, it will redirect you to Win Server 2. And this is sort of good because you are able to sort of trick it into being a specific port, but it's not the purpose of the Azure Load Balancer. And obviously, if someone is patient enough to do port scanning on your public IP, he will end up reaching the right machine. So the solution we do see quite often is being used is a jump box. And I guess you're familiar with that, but I'm gonna overview it real fast. What we basically say is we don't want our machines, our real precious production machines, to have a public IP. So what we will do, we will deploy in a private different subnet a jump box, a machine that will have a public IP. This machine's single purpose would be to be able to authenticate us to other machines in other subnets. And basically, this machine will probably be attacked quite often, but then after this machine who has public IP, you were able to authenticate and log in through it, you will be able to be, from that machine, to authenticate yourself to other machines and to other subnets. So this is obviously the best approach we've seen so far, but as Microsoft sees this kind of deployments as a very common best practice, we decided to go and give you it as a managed service. So Azure Bastion is basically all this fancy explanation we're just going through jump box. Azure Bastion is simply a managed jump box. And the way I would refer to it is, instead of having to configure a subnet and then put there's this machine, and also, by the way, pay for it 24/7 as a machine that is a jump box, and also protect it and update it and patch it and make sure everything works on it, then you are basically able to deploy an Azure Bastion instance. You do have to configure a subnet before, and it needs to be named in with this name convention of Azure Bastion subnet with the capital characters. Believe me, I've tried this. But basically, what it means that we allow you sort of to connect. And you can see that on every Azure VM you connect to, you can have SSH or RDP, and then you can also have this Azure Bastion. And the good thing about it is that actually for your VMs, you no longer have to provide any kind of public IP. They have only private IPs, and they're only accessible from the Azure Bastion. And we give you this jump box as managed and secured, and it's an instance deployed in your VNet. And basically, anyone who wants to get to any kind of VM, no matter around the world where he is, he needs to log into the Azure portal. Then he needs to be able to log into the Azure Bastion, and he can do that with, again, his Azure AD credentials, which is awesome. And then just only from there, he can log into his machines. So basically, we get all of that without having a single public IP, not even for the jump box as we used to. and all the traffic is encrypted. We have SSL termination and TLS termination and SSL offload and all of that. And it only exposed on 443, obviously.
Sorry for interrupting you, but we should start finishing your session, and we have the
Yeah.
break session. So just I'll let you wrap up your session.
Yeah, no, I was already finishing. So, and this is actually, I think, my last slide. The only another thing that again bring me back to the list privilege is making sure that just as we said we have that privileged identity management to have just-in-time VM access, because also some VMs shouldn't be accessible all the time, even if it's through a Bastion or something. So we can also make sure that VMs can be, you can log into certain VMs only in a certain scope and only for a limited time frame. So again, this is the way it looks. You can either RDP, and then this request access basically means we have just-in-time access enrolled on this virtual machine, or use SSH or Bastion. That's it. I think I covered everything I wanted to. I will flag those session takeaways. I hope you got some ideas here of how to integrate your services with our authentication mechanism, and why is having a strong authentication mechanism in place is important. It was a real pleasure. Thank you, Dan, for having me.
Thank you, Shiri. Your session was really awesome, as usual. And so really thank you for joining our Hackorona webinar. Now I'm gonna remove